Thank you very much, Thomas, and thank you very much to all the DataOps organization for inviting me to this session. I'll just spend a couple of words about myself. I'm a core developer at OrientDB. Now OrientDB is part of SAP, so I'm now part of the big company. And today I'll talk a little bit about the product itself, about OrientDB itself. I'll show you a few of the features, and I'll also try to show you a demo and demonstrate a little bit how it works. So I think I can get started with the presentation unless Thomas and you guys have something else before.
Now the stage is yours. You are start today.
Perfect. Okay, so let me share my screen. Here we go. And the presentation, I hope you can see it.
Yes.
Okay, so perfect. Thank you. So talking about OrientDB, and here you can find a couple of let's say useful information. I'm Luigi Dell'Aquila. That's my Twitter handle. And of course, OrientDB website address that is just orientdb.org, where you can find everything. But let's start from the beginning. So what is OrientDB? I called it a scary intro. You'll see why in a minute. Of course, OrientDB is a NoSQL database. So it's let's say a new generation database, non-relational. NoSQL in the sense that it doesn't have tables. So you don't have a structured tabular data model. That's it. It's Apache 2 licensed. That means it's free open source software. You can download it, use it, modify it, embed it in your applications, deploy it, sell it together with your applications, and without any, let's say, economic obligation, at least for the OrientDB Community Edition, that is the very, very big part of OrientDB. It's a transactional database, but it's not so common, at least for the first generation NoSQL solutions. We think ACID transactions are important. Data quality is a big value for a database. Losing a transaction is not an option in so many scenarios. So we decided to go with a transactional approach. It's completely written in Java. So this means many of you will probably know Java. It's a language that is also easy to approach for many reasons. So it's easy to embed in your application in case you want to embed it. It's also easy to contribute, and of course you can, because OrientDB community is a very open source community, and we have more than 100 community contributors that provide pull requests and so on. So if you have a chance, have a look at GitHub repository. You can check the code, contribute, and all the rest. It's a document database. So every record in OrientDB is a document, is an unstructured document that is like a map with nested properties. We'll go deeper in detail about that. It's also a graph database. That means that the document in OrientDB can also be a vertex, or it can be an edge. And we will see that we're not talking about symbolic references or foreign keys, let's say. We're talking about physical connections that make graph traversal extremely efficient. So you'll have an excellent performance when traversing hundreds or thousands of relationships in depth. OrientDB has TinkerPop support. That is, let's say, the standard for graph databases. OrientDB supports a schema. Most document databases are schemaless. OrientDB can work as a schemaless database, but it can also work as a schemaful database. So you can define the properties for your data types. And you can also use a mixed approach. So part with a schema, part without a schema. It's embeddable, as it's written in Java. So if you have an application that runs in a JVM, you can embed OrientDB inside the same JVM and run it together with the application without networking, without all the burden of marshalling of messages and so on. And you will gain even more performance. It's a distributed database. That means you can deploy it in a cluster, have high availability, fault tolerance, load balancing, and all the advantages of a cluster deploy. It's a NoSQL database, but we decided to go with SQL language, so SQL query language with extensions, of course, because SQL was not designed to work with documents or to work with graphs. SQL was created in a relational world. So when you think about SQL, you think about tables, but SQL is really flexible. And it's also very well known, so everybody knows it. I'm sure you all know a little bit of SQL at least. So we decided to go with that for this reason, because you already know that, but we extended it to support document and graph capabilities. We added also new capabilities in the query language, like pattern matching, that is really, really effective when working with graphs. And we will see it in a few minutes. And it's not a separate query language. It's part of the SQL. So you can mix, select, update, delete, and so on with match statements and pattern matching. OrientDB has many indexing capabilities. It has traditional B-tree indexes. It has hash indexes that are faster for some use cases. It has full text indexing. It also has geospatial indexes. So you can index points on a map and do bounded queries like find all the people who are at most 1 kilometer away from a single point on a map. This kind of queries. OrientDB has a REST JSON API. That means you can do HTTP calls to OrientDB server and get JSON as a result of your queries. You can connect OrientDB to relational databases with a tool that is called Teleporter. That is part of the main OrientDB distribution, by the way, and it's also open source. And OrientDB will do the translation for you. So it will transform the relational model in a graph model, and we'll create the schema for you in OrientDB, and we'll also copy the original database, the original relational database inside OrientDB, so that you can start to play with that in a few minutes. And it's really effective when you have an existing database, existing knowledge somewhere else. There's also an ETL written in JSON that can import from other data formats like XML or JSON or CSV. So you can connect it to other data sources. And of course, it has native drivers for Java, Node.js, but also for other languages like Python, PHP, .NET. A few drivers are maintained by the core team. In particular, the Java driver and Node.js driver are part of our development pipeline. Other drivers like Python, PHP, and .NET are contributed by the community. So there are external teams in the community that provided the drivers and that support them. There's also a user interface that is called OrientDB Studio. I show you also that allows you to do queries, but it also allows you to manipulate the schema and also to query the graph in a visual way. And this is just a few. This is why I call it the scary presentation, because it's a lot of things all together. But that's more. OrientDB also has full and incremental backup restore, object API, JDBC driver, Spring data module contributed by the community, some additional profiling and monitoring capabilities in the enterprise. So in SAP Enterprise OrientDB, that is the enterprise version of OrientDB, we have an official Docker image, and it also can work as an in-memory database. So if you decide not to store your data on disk, you can just go purely in memory. There's more actually, but the list is pretty long already. So let's go to the features. I said OrientDB is a native document store. A document in OrientDB is an unstructured record that is like a JSON or like a map. An attribute in a document is just a pair of a name, that is a string, and a value. The value can be a simple type, like a relational type, so a string, a number, or a Boolean value, but it can also be a more complex element, like a collection. That could be a collection of strings or a collection of numbers, but it can also be an embedded document. So documents that contain other documents in a nested structure, and collections of documents in a, see how deep, as deep as you want. So you're not limited to a single level or to two levels. You can have multiple nesting levels. You can define the schema for this. So you can say the customer class has a name and a phone number, but you can also work schemaless. So just create two different documents with two different structures without any checks. It's very developer friendly because you don't have to care about the schema from the beginning. You can just start to code, store information inside the records, and retrieve it as your application knows that. Then later, when you need data quality, when you need to enforce the schema, you can go back, create the schema, make sure that OrientDB does all the checks and guarantees the data quality, let's say. But from the beginning, for instance, for prototyping or for the early development stages, you're up and running in a few seconds. You just take a document, store attributes, and you're done, and you save. It's also a native graph store. That means that a vertex or an edge can be represented with a document. Here, I have to add a little detail. Every document in OrientDB has a record ID. A record ID is just a pair of numbers. You see here the vertex called Luigi has a pound 1355 number on top. That's the record ID. The first number is an identifier for a file on disk. So we call that a cluster or a data file. It's like a collection of records. The second number is a pointer to a physical address of that specific record inside that data collection. If you know the record ID, you can read the record with a single operation. So you don't have to do index lookup. You don't have to do any expensive operations. You already know where to look up with a single, actually with two disk or memory operations. Typically it's only memory, so there's a cache. So typically these operations are made in cache. So with a single operation, you get the record. Record IDs can be used and are used inside OrientDB to create links. So you can have record ID attributes that link to other records. In this case, my Luigi vertex has an out attribute that is a record ID. So it's a reference to another document that in this case is an edge, that is the visited edge. The edge has two more attributes, still called out and in, that point to, the first one points back to Luigi, and the second one, so the in attribute, is another record ID that points to another vertex. In this case, it's New York, that has another record ID. Now, traversing this data structure is just a matter of reading the record ID and doing a single memory access. So it's really very, very efficient. The cool thing is that doing the traversal of this graph relationship has the exact same cost if you have 2 records, or you have 2 billion records, or you have 200 billion records. So the traversal time is constant. It does not depend on the database size. And this is really, really important when you have to work with big data. In the field, we call this index-free adjacency. It means that you don't need to do calculation. When you have, try to compare it with a join operation in a relational database. When you do a join, you rely on an index, first of all. You do a Cartesian product, and it has a big cost. And the cost changes a lot when your tables grow up. So doing a join between 2 tables that have 1,000 records is completely different from doing the same join between 2 tables that have 10 billion records. With OrientDB, this is not the case. You don't need joins. You don't need to do calculation. You just do physical link traversal. And the physical traversal has the exact same cost if you have 3 records or 3 billion records. So this is fast. This is designed to manage relationships in a really fast way. The cool thing is that, of course, you can traverse a single relationship. So you can traverse this single pattern like Luigi visited New York. That's fine. But imagine the scenario when you have to traverse a chain of relationships. And I'm not talking about 2 levels or 3 levels. I'm talking about 100 or 1,000 levels deep. Imagine doing a query in a relational database where you have 1,000 joins. So table A, join table B, join table C, join table D, and so on, for 1,000 levels. It's just impossible. It's not something you can do. Now, this is where native graph databases make a difference. This is something you can do only with a native graph database. And OrientDB is a native graph database because of physical pointers. So we have documents, we have graphs that are actually 2 aspects of the same data structure. You know, a graph vertex is also a document. So it can contain embedded documents, it can contain collection attributes, and so on. So you have both together. You don't have to choose. You have all the power of the document, all the power of the graph together. The cool thing is that you can, as I said, you can enforce a schema on top of that. So you can decide to define your data types. In particular, you can define your data classes. So we liked to have yet another concept in our data model. We didn't want to have collections. We didn't want to have tables. We didn't want to have that kind of data-only data structures. We wanted something that was more close to the development part, to the application side. So we decided to add yet another concept to the data structure, that is object-oriented information. So in OrientDB, you don't have tables, you have classes. And you have classes with the same concepts you have in the programming language. So you don't do create table person. You do create class employee extends person. So you have inheritance, multiple inheritance actually, and you have class hierarchies, and you have polymorphism. So you can do polymorphic queries on your data. And that saves a lot of time if you, and you probably did. So if you happened to write an application that has a complex class hierarchy on the data level, let's say. So you have to save data that has a class hierarchy. Mapping that class hierarchy on a relational database or on a database in general is always an extremely complex task, because this is not concepts you find typically in databases. In OrientDB, you can easily do that because classes and class hierarchies are a native concept. Now, your classes can be just placeholders or collections. So say you have person class, you have employee class, you have no order class, and so on, and then you store whatever you want inside the records. But you can also have a schema declare on that. So you can define that the person class has a name and a surname, and the employee class extends person and has an employee ID, and the employee ID is a string, and it is at least 10 characters long and at most 12 characters long, and it has to match a regular expression, and it is mandatory, and so on. So you can have constraints on your attributes. As I said, you have classes, properties, class hierarchies, and multiple inheritance. About data types, I already gave you some hints before, but here I have a full list. You have strings, numbers, dates, binary data formats, embedded documents, embedded collections, links, so physical pointers between documents, and collections of links and maps as well that are more or less like documents. It's a bit overlapping, but sometimes it makes sense to have them as well. So this is OrientDB data model. Now let's see how to interact with OrientDB. Let's say the most natural way, as OrientDB is written in Java, is the native Java API, of course. So since Java is one of the most widespread programming languages, I'll describe that. But I can say that you can do the same with Node.js, for instance. So the concepts are one-to-one. This is how you interact with OrientDB. You just open an instance, you connect to a remote server with a password, of course, and then you create a database. You say you want a plocal database. Plocal is just a data format for disk-based databases. And you have a database session. Now, with this DB object, you can do data operations directly, like you can do db.newVertex or new edge and create data types and create records. And then you can take these records and do set property, get property, like, you know, in Java, it's getters and setters, more or less. The cool thing is that you can do the same, just changing the connection address from remote to plocal, and you won't have a remote connection anymore, but you'll have an embedded in-process OrientDB server inside your application. All the rest is the same. So the queries you write, the data manipulation, the object storage, and so on, doesn't change by one single line. You're changing just the connection or the connection address, and you pass from a remote connection, client-server connection, to an embedded OrientDB storage. And you can do the same with memory. So you don't want a physical database, you just want a memory-only database. You change the database creation, and you have an in-memory database. Same APIs, same features, same everything, same query language, same, the same thing. It's completely transparent. That's huge when you have to do testing, for instance. So consider you have an application deploy based on microservices and based on multiple components that work together with a big deploy. But you have a database that may be, or multiple databases that maybe include multiple schemas and a lot of data. Now you want to unit test, and you don't want to recreate the whole database structure. You don't even want to run a database server because, I mean, it could be complex when you just write a unit test to have an OrientDB instance running. Now you can just switch to an in-memory connection. You start your database inside your Java process. You do your unit tests, and that's it. Then when you deploy to pre-production or to test environments, to bigger test environments, you use maybe an embedded deployment with a single node. Then you go to production and you enable a clustered distributed deployment. All the rest is completely transparent. You don't have to change a single line of your configuration or your API calls or your application logic, because that's completely transparent. This is how you manipulate objects. So for instance, you create schema. You see, the first instruction is just db.create vertex class. I'm creating a class called person. And I say this class has a property called name, that is a string, and another property that is interests, that is a linked list. So it's a list of other records, let's say, other pointers. Then I do the same to create an edge class. I call it friend of. So it's just db.create edge class. And then I can start to create data. I can do just db.newVertexPerson, and I'll have an oVertex instance that is a live object. So it's something you can interact with. You can just do set property, get property, and save. So you do John set property, name John. Then you set the property on another vertex. Then you add an edge between the two. And at the end, I forgot to add it here. You just do vertex.john.save or db.saveJohn. It's the same, it's a shortcut. And the data are immediately stored in your database. You can surround this with a db begin, db commit if you want it to be transactional. And as you can see, the API is extremely easy to use. It's really a matter of seconds. That's all you have to know. There's only one additional thing that is another two methods that are db.command and db.query, and you'll need them to execute SQL. That's it. This is all the OrientDB API you have to know to write your applications. That's really all. And here we go. That's the other API. Result set equals to db.query, select from person where name equals to John. And then you have stream API that allows you to iterate the result set and to get the properties. As you can see, the API is the same. I do x.getProperty name. So I have set property on the records, I have get property on the result set and on the records. That's pretty straightforward. Of course, I said we have SQL, but SQL is not enough for a document database. We need something more. Look at this example. Consider you have nested structures. So a document that contains another document that contains another document that contains a collection, maybe. And you have to inspect this information. The most natural way to do that is to use dot notation, like you do with, when you query with Spring Data or with Hibernate. That's just dot notation. You already know that. So in this case, I do select from person, where interests contains tracking. So interests is supposed to be a collection of strings, and I use a contains operator to check if the collection actually contains a string. And then I have friends whose age is greater than 20, .address.city contains London. So let's say, give me all the people I know who are at least 20 years old and who live in London. So whose address.city attribute is London. So not complex, it's plain select. You just have dot notation for embedded documents and for links, it's the same. And you have square brackets for filtering. So you can add conditions inside square brackets and they will filter collections. But also for selections. So you could do friends, square brackets, 1. So give me the second item, so 0, the first one. First item or second item of the collection. That's like an array. And of course, you have JSON. So you can do insert and data manipulation using JSON syntax. Like you see, insert into person, content, and you pass a JSON document. It's very, very natural. It's very close to what you already do with SQL, but it's also very close to what you do with JavaScript or with JSON in general. So it's all concepts you already know, nothing new to learn. Of course, there's also standard SQL notation. So you can do a plain insert as you is for select. You have nestions and you have some additional syntax to include, exclude, and filter information by document. SQL operators, you have the standard operators, let's say, so plus, minus, mathematical operations, math and assign operations, comparison, bitwise operators, string and collection concatenation, and then you have Boolean conditions like and or not contains, contains any, contains all, in, contains key, contains value, like, is defined, is not defined, between, all things that you will need when you work with collections, with schemas, data types, and with nested data structures. As you see, there's all you need, but it also blended inside standard SQL. So it's very natural. A couple of examples here. Dot notation to find and navigate attributes. Square brackets to select or to slice arrays or collections. Square bracket notation, again, to filter based on embedded attributes. This is the extension for the documents, but we also need an extension for graphs. And this is easy. We just added a few graph operators like out, in, and both functions that actually traverse outgoing edges, incoming edges, and edges in general. So in this query, I'm doing select out friend of dot name from person. We're starting from a specific point. So what this query is doing is a two-level graph traversal, and then collecting the name it finds from the connected friends of friends, let's say. This is simple. Again, we have out, in, both to have vertex to vertex traversal. There's also out E, in E to have vertex to edge traversal, so that you can also retrieve information that are on the edges. There's more. There is a traverse query syntax that allows you to do deep traversal. See this example, traverse out friend of from something, while depth is less than 6. So get all the friends of friends to a depth of 6 levels. That 6 could be a 600 or 6,000. It doesn't make a big difference as long as you don't load billions of records in the same query, because otherwise you'll just have problems of the client. I mean, too many data. But I mean, if it's just about a matter of traversal depth, for OrientDB is not a concern. You can do that. And again, pattern matching. This is slightly different from what you do in SQL. In this case, it's more declarative. You declare a pattern. You see, there's a person. I call it me. I give it an alias. And I give it a few conditions like name equals to Luigi. So checking a person. And then I define patterns. So me is connected to a friend with a friend of relationship. Me is connected to a company with a works for edge. And the friend is connected to the same company with another works for relationship. So I'm defining a graph pattern. I'm just describing vertices with curly braces and edges with arrows. So it's pretty natural. I can define the pattern with arrows left to right or right to left, or with let's say undirected arrows, so connections regardless of the direction. And you can add conditions on any part of the pattern. So you see a work condition on the person, but you can have another work condition on the company. And you can have deep traversal conditions on the single traversals. So you can do things like traverse that friend of relationship up to 3 levels. That's pretty natural. So this way you can build standard OLTP queries, but sometimes you need something more. You need algorithms to do, let's say, graph intelligence. So sometimes you need the shortest path, sometimes you need a more complex algorithm. OrientDB has some built-in graph algorithms like shortest path, Dijkstra, A-star, but it can also run TinkerPop programs, and you can find algorithm libraries on TinkerPop based on TinkerPop's stack very easily. Just a couple words about Apache TinkerPop and Gremlin project. TinkerPop is a programming interface. It's supposed to be some kind of graph standard. Many people consider it as a standard, and it allows you, at least on paper, to switch from a graph database to another one. So you just write Gremlin TinkerPop implementation, then you can switch from OrientDB to something else, or from something else to OrientDB, hopefully. TinkerPop is a programming stack. Gremlin is a query language on top of TinkerPop. The Gremlin console is just a console to interact with that, and Gremlin server is a whole architecture. OrientDB is shipped with a Gremlin server inside, so you can have a standard Gremlin server running inside your OrientDB and interact with it with standard TinkerPop Gremlin APIs. The concepts are the same. So in Gremlin, you have vertices, edges, the graph properties, the traversal, and also graph compute. Graph compute is a particular feature, is not fully implemented in OrientDB, by the way. We have to spend at least a couple of minutes on the architecture you can design with OrientDB. OrientDB can run standalone. So you just start your OrientDB server, you connect from your application with a remote connection, like a MySQL, like any other database. OrientDB can run in process if you have a JVM. So if your application is written in Scala or in Java or in any other JVM language, you can embed OrientDB inside your process. You can deploy OrientDB as a cluster of replicas with fault tolerance, high availability, and scalability. And your application will connect to the cluster without any changes. That's the exact same. So you can switch from a single instance to a multi-master replica instance, just changing the connection address. But you can also mix these approaches. So you can have a cluster of OrientDB standalone replicas that are in a replica with an embedded OrientDB instance. So your application can become part of an OrientDB cluster. This is very flexible because each one of these deployments has advantages and disadvantages. So a single instance is pretty flexible. You can start and stop, and it's pretty easy to maintain. A cluster is much more scalable, it's much more reliable, and so on. But an embedded application is much faster because you don't have network between the application and the database. So for some scenarios, an embedded OrientDB is 10 times faster than a client-server instance. So if you need excellent performance for one of your, let's say, microservices or applications, you just deploy that particular part as an embedded replica, and you're good. Again, REST JSON API, so you can do queries via HTTP, sending JSON and receiving JSON. You can execute queries, of course, on HTTP API. And you can also define JavaScript functions inside OrientDB, and you can use these functions as store procedures, as triggers, but also as REST endpoints. So it's pretty flexible. That's it. It took a while, but we are at the end of this slide deck, and it's time to show you something real. So let me stop the presentation and switch to the demo. Let's cross fingers and hope everything works fine as usual. So before I switch, do you have any questions or I don't see the chat. Here it is. Okay.
Yeah, maybe I can read. Okay.
Okay.
Yeah, there is one or two technical questions. So, is there a way to capture some part of the remote databases and create in-memory version somehow? An application is to create a fast in-memory version of the database in a mobile application.
I got the point. No, there was an attempt a few years ago to bring OrientDB to Android and to a completely mobile version, but it was never complete and it was abandoned. And unfortunately, there's no option so far to have, let's say, partial copies of the databases in memory replica. There are some caching mechanisms, of course. So when your replica uses only a portion of the database, only that part is stored in memory, and it's very efficient because of 2 layers of cache that are off heap, disk cache, and database level cache. But that's a bit different. I mean, so I'm afraid the answer is no. That's something we don't have now.
Okay. The next question is from Philip, but it can wait. So let's go through the demo. Okay.
Okay. So, oh, I see a few more questions here. Okay. Okay, so let's go to the demo. Then we'll go through a few more questions. So I have an OrientDB package here that is exactly what you have, what you download from the website. So we will install it from scratch just to show you how easy it is. You just have to unzip it. Okay, expanding, and here we go. This is OrientDB. This is ready. You have a bin directory that contains the executables and the databases directory that contains the databases. Now let's copy this thing. We'll call it 1, and copy it. Okay, I'll create 2 instances in a cluster and call it 2. Okay, now let's go back to the console. Can you see it? Let's. Okay, I hope you can read it. So let's do the OrientDB1 bin. Okay, so this is my first instance. Let's do the server. We are starting a, sorry, let me shut down my VPN, turn off. Okay. Okay, this is OrientDB starting. As you can see, I didn't do any install. I just copied the installation. That's it. Now I need some. Oh no, wait. What's okay? I need to enter a root password, but it's bit2. Oh, my bad. Okay, here we go. Root. Let's choose a root password and let's give it a node name. I'll call it node1. Here we go. Now, as you can see, OrientDB is starting. And here we go. Now, let's go back to the browser and do studio. We'll open localhost 2480/studio address, and we'll get a connection to the web interface, OrientDB web interface. As you can see, there is a demo database shipped with OrientDB. Let's try to connect admin, and here we go. Now, I'll show you a couple of quick things, like you can do queries from here, select start from or user or from countries, let's say. Okay, here we go. As you can see, you can see a table representation of the, oh my, I have this thumbnail thing here that I cannot, okay. This is a table representation of the result set, but the actual result set is a JSON. So if you click on the row here, you'll see that this is actually a JSON. Now, that's fine, but this is actually a graph. So you can do the same in a graph tab and do select start from countries. And you get the countries. Then a couple, let me pick a node that has some entries connected, double click, and I get the graph itself. So I can start traversing the graph visually. And these entries have attributes. And if you click here, you can see the attribute values, and you can also edit them actually. So this is OrientDB Studio. This is not intended as an analytics tool. It's just to explore the graph a little bit, but it just supports a few thousands of vertices and edges in the same screen. You can zoom in, zoom out, but after a few thousands of displayed vertices, it starts to get a bit slow and too cluttered for real data analysis, let's say. So there are other tools actually. There is a tool that is called Arcade Analytics that you can connect to OrientDB to have to do proper data analysis, graph data analysis. Now let's go back to our main page. And let's go back to the console. Now let's open a new tab, temp, no, I don't remember how I called the folder. Oh yes, DataOps. Okay, so now here we have our OrientDB 2. Okay. So I'm starting another node of OrientDB. By default, OrientDB is configured to auto-discover other nodes. So they self-discover on the network and they connect to each other. Root, and we will call this node 2. So we have 2 nodes. Now you will see that the nodes will see each other and will start sharing the databases. Here we go. We have here we go. We have 2 members in the cluster. And that's it. We have our clustering deployment done. The database are getting aligned right now. And here we go. We are ready to go. Now, suppose if you look at the logs, you will see that the second node started on another port. The 2480 was busy, because it's busy for the first process. So it's using 2481. Okay, so let's go back to Studio. Let's log out and create a new database. I'll call it test, putting the root password, and create the database. And let's start to play with data. So let's do create class person. Okay. And let's do create class employee extends person. And here we go. Now I'll do insert into person set name equals Luigi. Okay. And insert into employee set name equals to Frank, and employee equals to 12. Here we go. These are my 2 queries. Now let's open another anonymous browser. Studio. Let's connect to the 2481. That is the second node. Give it some time. Here we go. Let's see. Test database is there. Admin. And let's do select start from employee. And we have our data replicated to the second node. Now, the cool thing is that if you do select start from person, you will see the person and the employee, just because the employee class extends person. So this is a polymorphic query. If you want to create a graph, you can do things like create class myVertex text type, extends V. V is the standard vertex class. And then I'll do create class myEdge type extends E. So E is the edge class. And then I can create vertex x my vertex type, set name equals full, and bar, bars, and so on. And then I can create edge, my vertex edge, from, let's say, from select from my vertex type, where name equals to full, to bar. I have my edge. I have a quicker way to do that. When I created vertices, I got the record ID. So this one, so the bar was 75.0 and buzz was 76.0. So I can say from 75.0 to 76.0. I can use record IDs as well. This is extremely fast. Now I can do select from, let's say from B, polymorphic queries. You see I have my 3 vertices with links to edges, and the edges link each other. Now let's do where name equals to full. Okay, let's pick the first one. Now let's do a traverse out from this one. Let's do the deep traversal. Oh, you see, we are traversing the whole graph structure, and it could be, again, 100 or 1000 levels deep. With a very simple syntax, you can get it. Now, let's suppose you have, let's say, a triangular relationship, like, let's copy paste. It's much easier. Okay, no. Okay. Now we have full connects to bar, bar connects to buzz. Let's also connect full to buzz, and let's see what happens. So going back to our graph, select from V. This is our pattern. We can also decide to show something else. So display the name and save. So we have full that connects to bar, bar to buzz, and full to buzz, to edges. Now we can define patterns here. So we can say match, I don't know, class V, where name equals to full, and say it connects to something else that connects to, to something else as a friend of a friend. Return elements. So this will return this one, so as A, let's say. This will return A and the friend of a friend. Okay, you see, first one and the last one. Now here I can add a condition where name equals to bar, and it will still match the condition, that's fine. Let's say I want something that has buzz in the middle. Nothing, of course, because this pattern does not exist. I can also do the traversal here. I can do a lot of things. And I can also do something more with this. So I can do update, let's say V, or my vertex class, my vertex type. Okay, update vertex type. Set no address equals to, and let's do something where name equals to full. So this is a vertex, but this is also a document. So I can add document attributes to that. Let's say street, let's call it full. And here we go, select from V. I have a JSON inside my document that has a straight full on address, but I can do something more, like city name equals to, no, row, sorry, this. Okay, now we have a JSON. If you see the row representation, you'll see this is a real JSON. Address, city, name, it's a nested structure. Now you can do queries like select from V, where address.city.name equals to row, and you'll get that specific record. This is network representation. There are no hacks here. The internal representation of the document is a native data structure. So there is no blob structures or big text or things like that. This is a structured document and it's pretty efficient. So this is what OrientDB is designed to do. As you can see, here we have document database, graph database together. We have an easy query language. We have a deploy in a cluster that takes seconds to be from download to go live, and again, it's pretty easy to work with. You know almost everything. One more thing, the functions. So let's create a function and let's call it test. We'll write in JavaScript. Let's do return. No. Let's also add a parameter. Let's call it hello. The name. Let's return hello plus the name. That is the parameter I have here. Let's save it. Let's go back. This is plain JavaScript. Let's go back here and let's do select hello name from B. You see, hello full, hello bar, hello bus. So again, there's nothing to learn here. There's plain SQL with a few extensions. There is JavaScript for the server-side functions. There is no particular configuration or operations to learn. OrientDB is designed to connect in a full replica cluster without any configuration, without a discovery, and with commodity hardware. I'm running on a MacBook Pro, but you can run it on any machine that has a JVM, and JVM Java 7, Java 8 is absolutely fine to run it, and that's it. It's designed to be simple. So that's what we try to do, and that's what we are trying to keep doing. OrientDB is a big project. It's almost 10 years now that we're developing this project. The community is really big. We have tens of thousands of community installations in deploy. Probably we don't know all of them. We receive messages, contacts every day from users. I cannot call customers because we also have enterprise customers, but most of the user base, OrientDB user base, is from the community. So people that just pick it, use it, and you just don't know. I mean, you're happy about that. You contributed to something bigger probably, but maybe you don't know them. We have more than 100 contributors to the source code from the community. So people who wrote part of OrientDB code base, like pull requests, new features, fixes, or tests. And this is it. OrientDB is Apache 2 license. So again, this is OrientDB Community Edition is free open source forever. So this is what I wanted to share with you. There is much more. Of course, I could go on for hours showing many more features, the Java drivers, Node.js, and so on. But I guess it's time to switch to questions, to Q&A.